Jai Shri Krishna, Mitro, friends. Last time we can study the geometrical isomerism in cyclic compounds. Cyclic compounds is a cycloalkane or cycloalkenes. Now we can study the geometrical isomerism in allenes. Geometrical isomerism in allenes. This is the new topic for us. First question is that which type of compound is known as allenes? Then we can say that generally consecutive dienes is known as allenes. Generally consecutive dienes is known as allenes, like C3H4, like C3H4. Consecutive means back to back. Consecutive means back to back. If double bonds are back to back, means that there is no single bond between the double bond. Double bond, double bond, double bond. It is consecutive double bond. If the double bond pattern is like that, double bond, double bond, double bond, double bond, there is no single bond between them. Therefore, this type of double bond is known as consecutive double bond. Is known as consecutive double bond. If we can have any compound in which double bonds are back to back or consecutive double bonds, therefore you can say that this compound is allene. We can have C3H4, CH2 double bond, C double bond, CH2. Yes, we can say that this is allene because it can have consecutive double bond. એક પછી એક કાર્બનના ડબલ બોન્ડ કન્ટિન્યુ જ રહેતા હોય તેને consecutive double bond કહેવાય. Clear? Yes, it is allene. What is the concept? Concept is that if even number of consecutive double bonds is present in the allene, if even number of consecutive double bond is present in allene, then it does not show GI. Even means 2, 4, 6, 8, whatever. Even number means 2, 4, 6, 8, 10. If any allene can have even number of consecutive double bond, here even number 2, here also even number 4. If it is like that, therefore you can say that it is odd number, 3 consecutive double bond. If any allene have even number of double bonds, consecutive double bonds, therefore it does not show the GI. Why? We can give the reasons. But first of all, we can show that if we can have any allene which can have odd number of consecutive double bonds, therefore this allene shows the GI. Concept clear? If allenes have even number of consecutive double bond, it does not show the GI. If odd number of consecutive double bond is present in allene, then it does show the GI. Why? We can give the reasons, but first we can take some example. Suppose here we can have a compound like that, H, C, CH3, C double bond C, C double bond C, H, CH3. Yes, it is allene, but this allene does not show the GI. Why? First of all, we can say that there is even number of consecutive double bonds, 2 double bonds, even number. Therefore, it does not show the GI. But what is the reason behind this? Why it does not show the GI? The reason is that because areal distance of group is same. What is areal distance? We can discuss in last lecture. Areal distance means distance of 2 similar groups in space is known as areal distance. Distance of 2 similar groups in space is known as areal distance or space distance. Here, in consecutive dienes which can have even number of double bonds, the areal distance is same in the both form. The areal distance is same in the both form. Therefore, it does not show the GI. We can understand why areal distance of this group is same. Anyone can say that, sir, you can write this form, and suppose if you can write the form like that, H, C double bond, C double bond, C. Here we can write CS3, H and H and CH3. Now we can measure the distance, it is like that. And here distance is like that. Distance is different. No, friends. Distance is same. Because we can know the symmetry or geometry of this compound. Clear? If you can draw the structure of this compound, the structure is like that. Here, we can have a XY plane. It is a XY plane. Any doubt? In XY plane, we can have H, C, CH3 and carbon. H, CH3, C and double bond C. And these all are planar due to the sp2 hybridization of this carbon. Due to the sp2 hybridization of this carbon. Clear? Therefore you can say that it is XY plane. In XY plane, here hydrogen, here CH3, here C, and double bond C, all are in a one plane. And now if you can think about the YZ plane, it is like that. It is a YZ plane. It is XY plane, it is YZ plane. Now we can think about this. In YZ plane, here carbon, this one is here. Here hydrogen upside, and here CH3. It is the like that. H, CH3, C, double bond C, here C, C, H and CH3. Now we can think about the aerial distance between these two CH3s. Here CH3 group is there, and another one is there. We can say that the distance is like that, here to here. Clear? Now we can draw the another form, and we can say that if this distance is x, if this distance is x, here we can draw the another form like that. It is the structure of this form, and it is the structure of this form. If we can show these structures, first we can say that distance are different. But if we can think about the geometry or structure, we can say that the aerial distance are same. Here also x, here also x. If we can think about this compound HCH3, C double bond C, C, CH3H, it is XY plane, it is YZ plane. If we can think about XY plane, here hydrogen, here CH3, here C, here C double bond C, planar because of the sp2 symmetry. Here carbon, upside CH3 and downside H. Here carbon, here CH3 and here H. In our case, here hydrogen and here CH3. Plane is like that. Change is that. We can convert the position of hydrogen and CH3. Clear? Here CH3 remains constant. Now, in first case, we can measure the distance. It is like that. This one to this one. You can measure that. This one to this one. Means that it is flat, it is like that. Now CH3 is here. In this case, if we can measure the distance, now here CH3. Between CH3 and CH3, it is also like that. Here like that, here like that. We can say that this distance and this distance is same. Yes or no? Therefore, we can say that aerial distance is same. Therefore, the allenes in which even number of consecutive events are there does not show the GI. Concept clear? Concept clear? We cannot draw the 3D, but the explanation is like that. It is XY plane, it is YZ plane. It is XY plane, it is YZ plane. In first case, distance is that. In second case, distance is that. That distance and that distance is same. Therefore, we can say that this type of compound does not show the GI. Now, if you can think about the pi bonding and sigma bonding and geometry in this compound, which can study here, HCCH3, double bond C, HCH3. If you can draw the diagram or molecular orbital diagram, then the picture is clear. Therefore, we can draw the diagram or we can understand this. First of all, hybridization of this carbon is sp2. This carbon undergoes sp, and this carbon undergoes sp2 hybridization. Here sp2, here sp, and here sp2. Clear? sp2, sp, sp2. Here carbon, here also a carbon. Carbon, carbon, and here also a carbon. Carbon have 4 bonding orbitals. Now, if you can think about this hydrogen, then one p orbital of carbon and s orbital of hydrogen undergoes sigma bonding. One p orbital of carbon and one p orbital of carbon from methyl group undergoes sigma bonding. Here one p orbital of carbon and one p orbital of this carbon undergoes sigma bond. Now one is pi bond, sigma, sigma, sigma and pi. Now one p orbital of carbon is not bonded. Here also one orbital is not bonded. Therefore, you can say that if you can think about this XY plane, here carbon, hydrogen, CH3 and carbon. This is the carbon first and this is the carbon second. Here a p orbital which is unbonded. Now it overlaps to each other and form a pi bond. It undergoes to overlapping and form a pi bond. Clear? And first concept is that hybridized orbital perpendicular to pi bond in sp2. Hybridized orbital is perpendicular to pi bond in sp2 hybridization. If these orbitals are undergoes sp2 hybridization, then pi bond is perpendicular to this. These all orbitals are in this form, in this space, in this plane, but pi bond is perpendicular to the sp2 hybridized orbital. These are the sp2 hybridized orbital. Remember that in sp2 hybridization always hybridized orbital is perpendicular to the pi bond, or pi bond is perpendicular to the hybridized orbital. If hybridized orbital is present in this plane, then pi bond is perpendicular to that, we can say that, or we can see that. Now here pi bond is in a xy plane. Yes, it is like that. It is xy plane, it is xy plane. Now pi bond is in a xy plane. Therefore, due to the sp2 hybridization, here the bonded orbital is in a yz plane. Clear? YZ plane. Clear? So aerial distance is different, therefore does not show aerial distance is same. Aerial distance is same, therefore does not shows the geometrical isomerism. Clear? Here we can think about that. One orbital used here, second one used here. It is a third orbital forms sigma with this carbon. It is sigma with carbon, sigma with hydrogen. Now one orbital of this carbon and these carbons are remaining unbonded, which forms a pi bond. Which forms a pi bond, and this pi bond is perpendicular to the yz plane. Therefore we can say that this pi bond is in a xy plane. This pi bond is in a xy plane. Clear? Therefore aerial distance is same. Aerial distance is same. Clear? It is very important from the point of view of geometry. Now suppose if we can have a alene in which consecutive double bonds are in a odd number, therefore what is the condition, or how it can show the GI? HCCl, double bond C, double bond C, double bond C, HCl. Yes, it is alene, and 1, 2 and 3 consecutive double bonds which is odd number. Therefore we can say that it shows the GI. Therefore we can say that it shows the GI. What is the reason? Because odd number of consecutive double bond, and second reason is different space distance of groups. Different space distance of groups, which we can show here. These H, Cl and C are present in a xy plane. We can study here. Therefore second bonded atoms are in a yz plane due to this symmetry. And now if we can think about the third double bond, therefore it is in a xy plane. First bond xy, second yz, third xy, fourth yz, fifth xy, continue thigh. Clear? Now this carbon, hydrogen and chlorine and carbon are present in a xy plane. This carbon-carbon double bond is in a yz plane. And if you can think about this bond, it is now further in a xy plane. Here carbon, here hydrogen and here Cl. Therefore you can say that in this form, distance between this Cl2 is like that, because both are in the same plane. If you can draw the second isomer, HCCl, double bond C, double bond C, double bond C, Cl and H. Now this distance is different because here plane is different, but here plane is same. In first case distance is like that in same plane, but in second case distance is like that. Therefore you can say that x is does not equal to y. In first case distance is like that, in second case distance is like that. Therefore you can say that aerial distance is different, and this type of compound shows the GI. In short, alenes in which consecutive double bonds are in a even number, it shows the GI, and if consecutive double bonds are in an odd number, then it does shows the GI. Even number shows the GI, even number does not shows the GI, odd number shows the GI. What is the reason? Why? We can explain here. Now next point is geometrical isomerism in Spiro compounds. Geometrical isomerism in Spiro compounds. If even number of rings in Spiro compound is there, then it shows the GI. If odd number of rings in Spiro compound, it does shows the GI. Clear? Same thing. If even number of rings, in last case even number of double bonds, does not GI. Does not GI. If odd number of double bonds, here odd number of rings in Spiro compound, it shows the GI. Clear? Concept is same. Even number GI no show કરે, odd number GI show કરે. પણ ત્યાં ડબલ બોન્ડ હતા, અહીંયા રિંગ છે. સ્પાયરો કમ્પાઉન્ડમાં રિંગ હોય. Yes, we can study the Spiro compound. In Spiro compounds, two rings are connected to one common carbon. In bicyclo compound, two rings are connected to two carbon, which is common, two common carbon. Clear? Now we can study here. If we can have the compound like that, CH3H, one ring, second ring CH3H. Yes, it is Spiro compound. It is Spiro compound. This ring is present in a XY plane and this ring is present in a YZ plane. Which therefore you can say that this compound does not show the GI because the number of rings is 2, which is even number. It does not show the GI because same space distance of the group, because same space distance of the groups, which you can study with the help of planes. Here a ring which is in a XY plane, here H, here CS3. Here a ring but which is in this plane, here H and here CS3. Now if we can measure the distance between this CS3 and this CS3, it is like that. It is like that. If we can have a compound like that, HCS3 plane, ring, CS3 and H, it is the alternative of this compound. Here we can attach H and here CS3. Clear? Then we can think about that. If we can think about this H is here, CS3 is here, it is a ring. Second ring is in this plane in which here a CS3 and here H. Now if we can think about the distance between the CS3s, therefore like that. Here distance is there and here distance is there. Therefore you can say that same space distance of the groups, therefore it does not show the GI. If we can have the compound like that, HCS3, 1, 2 and 3 rings in Spiro compound, it is a odd number, rings 3, therefore it shows the GI. Because it is XY plane, it is YZ plane, it is XY plane. It is XY plane, it is YZ plane, it is XY plane, means that this CS3 and this CS3 are in the same plane. Therefore, in first case, distance is like that, distance is like that, distance is like that. And if you can draw the second form, means that if you can draw the compound in which here CS3 and here H, second form, therefore XY plane, YZ plane, farithi XY plane, means that plane is that. Now the distance, in first case distance is that CS3, CS3. In second case distance is that CS3, CS3. Therefore it is different and this type of compound shows the GI. Suppose a question is asked like that, if this Spiro compound shows the GI, we can calculate the ring 1, 2, 3, 4, 5. Yes. This is two different valencies, H and Cl, is here also H and Cl. If H and H or same groups are there, therefore it does not show the GI. It is the first condition of GI. Clear? 1, 2, 3, 4, 5. It is odd number, therefore it does shows the GI. Therefore, we can understand the geometrical isomerism in alene in Spiro compounds with the same way. If double bonds or rings in Spiro compound or in compound is an even number, therefore it does not show the GI, and if it is odd number, then it shows the GI. And last point of geometrical isomerism, which we can study here, geometrical isomerism in biphenyls. Geometrical isomerism in biphenyls. Note down that biphenyl and its derivative does not show geometrical isomerism. Biphenyl and its derivative does not show the geometrical isomerism because same space or distance of the group. Because same space distance of the groups. We can study here. It is a biphenyl. Phenyl ring, phenyl ring, biphenyl compound, it is a substituted because here CH3 and CH3. It is XY plane, it is also XY plane. Here a phenyl ring, here also a phenyl ring. But these two groups repulse each other. But these two groups repulse each other, and the repulsion is as strong as that it changes the plane of the second ring. Repulsion of group changes the plane of the phenyl ring. First of all, we can have the compound like that. Now these groups are repulsed. The compound. Therefore, this phenyl ring changes the plane. This phenyl ring changes the plane, and now it is in a YZ plane. Clear? It is XY plane, it is YZ plane. Now it changes the plane. Therefore, you can say that it is converted to this due to this repulsion, this plane is changes to YZ. It is XY, it is XY. This changes to XY to YZ. And if groups are present in different planes, XY and YZ, therefore we can say that the areal distance is same, which we can study in the consecutive double bonds, which we can study in the Spiro compound. Any doubt? Now if we can measure the distance, it is X, and we can change it, and we can have the compound like that: phenyl ring, here CH3, here also CH3, H and H. Here also a distance between the CH3 is X, and here also X, because in first example distance is like that, CH3 and CH3. In second example distance is like that, CH3 and CH3. Therefore this distance and this distance is same. And if we can think about the more number of rings, therefore more number of rings is not in our syllabus. Therefore you can remember that biphenyls and derivatives of biphenyl is not shows the GI due to the same or same areal distance of the groups. Clear? Now we can complete the geometrical isomerism in different compounds, like in alkene, like in nitrogen containing compound, in allenes, in Spiro compounds, in biphenyls. In next lecture we can study about the number of geometrical isomer of any compound, or we can also say that we can calculate the geometrical isomers of any compound. Clear? Suppose if you can have a compound and anyone can ask how many geometrical isomers are possible for this compound, therefore you can study about this in next lecture. Here we can complete the GI. In next lecture we can complete the calculation of number of geometrical isomers.